Hi everyone, in this video we're going to go over Leetcode, single number question. Major tech companies like Amazon, Facebook, Microsoft, LinkedIn are asking this question while they're conducting their technical interviews. I hope you will find this video tutorial helpful for your technical interview preparation. Let's start with reading the question. Given a non-empty array of integers, every element appears twice, except for one. Find that single one. Note, your algorithm should have a linear runtime complexity. Could you implement it without using extra memory? Example 1, and we are given the array and output is 1. So we are given an array. In this array, every element appears 2 times. So for example, these 2 appears twice. And there is one element that appears only once. Can we find that element without using extra memory and in one pass linear runtime complexity? So we can't use extra loops, and we cannot use hash sets, hash maps, etc. because without using extra space. So an example 2, in this case, for example, 2's appear twice, 1's appear twice, and there's 1, 4, that's a single one, so we return 4 here. Let's get on the whiteboard and try to solve this question. So this is an exclusive OR question. It's a bitwise manipulation and bitwise operation. Let's read XOR before we start the question. A bitwise XOR, or you can say XOR, is a binary operation that takes 2 bit patterns of equal length and performs a logical exclusive OR operation on each pair of corresponding bits. So we are performing exclusive OR operation on 2 corresponding bits, on bits here. The results in each position is 1 if only one of the bits is 1, but will be 0 if both are 0 and both are 1. In this we perform the comparison of 2 bits, being 1 if 2 bits are different and 0 if they are the same. So if 2 bits are same, they are 0. If they are different, they are 1. 2 bits are same, 0. 2 bits are same, so 0. So for example, 1 and 1, 0. 0 and 1, 1. 1 and 0, 1. 0 and 0 is 1. That's the exclusive or XOR operation. So how can we use XOR in this question? This is the logic here. This is our logic. And we know XOR is commutative and associative as well. That means we can use XOR in an array. For example, we can use XOR in this array. That's the same as implementing XOR in this array. So we can swap the numbers and implement XOR, will not make any difference. So for example, I can do XOR on 2 and 1. Then I can do XOR with the result of 2 and 1 and 4. Then result of 4 and 5, etc. So that will give me the same as doing XOR this way. This is about being commutative. So n1, n2, n3 is same as n1, n3, n2, etc. And this is also associative as well. So, for example, this is, if we use XOR in an array, this is the, for example, array items. If we do XOR between every item, and the result will be same as doing XOR between same numbers. If we do XOR between 2 same number, for example, in this case, 0, 0, 10, that will give me, think about these 2 numbers. So that will give me 0, 0 and 0, 0, 1 and 1, 0. 0 and 0, 0, 0 and 0, 0. I hope this makes sense. So the result of X or exclusive OR of two numbers give me the same number, gives me 0, like this. And this is being commutative. That means we can implement XOR of array like this, and it's the same as doing this way. Like 2 and 2, 4 and 4, 1 and 1, and 5. So this way, the result will give us 0, 0, 0, and the remaining item, that is 5. So how are we going to use this in the code? Let's see that first, then try to see how it works in the array. Okay, so we create an integer that holds the result, and going through the nums of items linked in a one for loop in linear time complexity, and implementing result on each item with exclusive OR SOR. And finally, this will find the single item, because all the other items will return 0. When you do XOR with the single item, that will not give you 0. So that will return the number that's left. So that's how we solve this question. Let's go back to the whiteboard and see how it works here. This is the idea about you can increment XOR in the array. For example, sorry, let's move this here. When I start at 0. And 0 and 4, that will give me 4. This is the first iteration. I have 4 in the integer, so I have 4 in my result. Then I implement 4 to next number. Then 4 to 1, second number. That will give me 5. Then I have 5. Then I'll do 5 to 2. That will give me 7. And 7 to 1, that will give me 6. And 6 to 2, back, that will give me the single number. That's 4. So that's the idea about being commutative here. Like n1, n2, n3 is n1, n3, n2. So we are rearranging it this way. Let's see this one. XOR, XOR 0 and 1, 1. 1 and 2, so we have 1 here, result. Result 1 and 2 is 3. Result 3 and 1 is 2. 2 and 2, 0. 0 and 4, 4. So it's like numbers are going back and forth while we're solving the question. This is the logic of using this solving this question. It may look a little distant in the beginning, but as you go through a couple of times, I'm sure you will understand. So you just need to understand this part. And then it should make sense. So also this part. So this is the idea. This is same as these two. So we are doing the same operation here, and that will give us the single number. Let's submit and see if it's going to work. So it works. It's linear solution, linear one pass, linear runtime solution, no extra space. And that's pretty much it. I hope you found this one helpful, and I have more videos coming up. If you subscribe to my channel, we can meet again in the near future. Thanks for watching. Goodbye.